There are multiple ways of cleaning a window, ranging from a simple squeegee and rag to a water-fed bowl and a boom lift. But hold on a minute, isn't window cleaning a laborious task that could be automated, all while reducing the safety hazards of cleaning at a height? Nowadays you will find robots that will clean your living room and even sewer drain pipes. But what about your windows? You might have seen robots like this one and that one. But do any of these commercially available devices automatically move from one window to the next? No, and that's where we come in. We present Winkmore, an affordable device that will automatically clean windows. For our current design, we have focused on the functionality of moving from one window to the next. Our robot is meant to be used on exterior or interior windows by individuals living in an apartment or house or by a company cleaning a building.
For our final design, we are focusing on the scissor lift mechanism to move our window mullions, along with stepper motors to activate the scissor lift, ultrasonic sensors to detect the distances from the robot to the glass pane and metal frames, and the vacuum pumps to hold the robot in place. We intend for our robot to move along a zigzag path on the window pane. Sensors will be placed around the chassis so that it can detect the mullions and move on to the next frame. We will now talk about each component in detail.
The mechanical function of our robot is made up of three parts: the chassis, the scissor lift, and the motor. Here's a quick animation of our motor in actual size on a 1.5 by 2 meters window. The chassis is made up of top and bottom frames screwed together. It contains elements like the ultrasonic sensors, vacuum pump, etc. It is 20 cm by 15 cm for each model. Key features on the chassis include the indentation for the vacuum suction, the slot to enable the scissor lift motion, and the indentation for the cleaning fiber cloth. The scissor lift mechanism allows for our robot to move vertically and securely across the mullion. We perform calculations to get the desired length and angles needed. Here are shots of our assembled scissor lift and chassis put together with rivets and mated to allow motion as desired. The motor is essential to drive the motion of the scissor lift. We chose to implement a lead screw linear actuator to move the scissor lift, which requires the use of a NEMA 17 bipolar stepper motor, a coupler, and a bearing to support. Here's a video of our scissor lift in motion.
Sensors. We used bottom sensors to measure the distance from the bottom of the robot to the glass pane and side sensors to detect the metal frame. After extensive research, we decided to use ultrasonic sensors as they can detect distances between 2 to 350 centimeters. They can also detect both glass and metal surfaces, which is vital for our project. Vacuum pump. In order to operate the robot on a window, we needed to find vacuum pumps that not only provided enough suction for the robot to stick onto the glass pane, but also allowed the robot to move simultaneously. We chose a mini vacuum pump that provided a maximum pressure of 250 kilopascals.
Let's look into our electrical diagrams. First of all, we have started our project with a basic C-sketch diagram that helped us to organize our components. In the next step, we have built our Eagle library for the components we have selected. These all devices have both footprint and symbol assigned for our PCB and schematic design. After that, we started building our schematic as it's shown here. This schematic includes all our library components and necessary wire connections. It also helped us to build our footprint as it's shown here. We have tried to keep our PCB design as compact as possible and also made 3D versions of those footprints in Eagle. By using Fusion 360 application, we can demonstrate our 3D version here.
The material chosen for the scissor lift and chassis was anodized aluminum 6061. This material was chosen because of its high strength performance, lightweight, and manufacturability.
After several surveys and interviews, we realized that there is a genuine need and want for a product in the cleaning industry. An affordable commercial robot that moves over mullions has not been built before, and we believe that our product can have significant social and financial impacts by eliminating safety hazards and automating window cleaning. Thank you.